Hello friends, this is Bindu Kumar here. Let's solve this question. In which of the following situations does the list of numbers involved make an arithmetic progression and why? So we have to look at the different situations, identify the list of numbers in it, and then see if that list of numbers make an arithmetic progression. So let's look at the situation here. It says the amount of money in the account every year when rupees 10,000 is deposited at compound interest of 8% per annum. So what is the list of numbers here? The list of number is the amount of money in the account every year. So every year we have to see what is the amount of money in the account, and then that becomes your list of numbers. Okay, so if I have to write it down, we can write it down as A1 will be the amount at the beginning of year, let's say, right? A2 will be the amount at the end of first year. A3 will be the amount by the end of second year, and so on. So how do we calculate this? So let me quickly erase this and we will see what we understand from the question. So we know that the 10,000 is deposited initially. This 10,000 rupees is called the principal, also denoted by capital P. So the principal is 10,000. So an amount of 10,000 is deposited in the account at the beginning of the year. Now, at the end of the first year, the amount has grown. How much has it grown? It has grown at a rate of 8% per annum of compound interest. So how do you calculate compound interest? To calculate the return from compound interest, we use the formula P into 1 plus R. R is the rate of interest divided by 100 to the power of N. N is the term or the number of years for which the amount is kept in the account. So using this formula, so we can say by the end of the first year, the amount in the account will be 10,000, which is P into 1 plus the rate of interest, which is 8%, divided by 100 into N. N is the term. Here it is 1 year. Similarly, if you want to find out the amount in the account at the end of 2 years, the formula will be 10,000 into 1 plus 8 by 100 to the power of 2 or square. So third year, now as you can guess, it will be 10,000 into 1 plus 8 by 100 cube or to the power of 3. Okay, so this becomes your list of numbers, correct? So here you have A1, A2, A3 and A4. So now we have to check if this list of numbers form an arithmetic progression. So how do you define an arithmetic progression? Given the numbers A1, A2, A3, we can say it is an arithmetic progression if it is of the form A plus D, A plus 2D and so on, where D is the common difference between the terms. Now D can be calculated as A of n plus 1 minus A of n. For example, D can be calculated as A3 minus A2, or it can also be calculated as A2 minus A1. So in an arithmetic progression, the common difference between different terms must be the same. Okay, now let's apply this formula to our list of numbers. So first we will calculate D equal to A3 minus A2. So we have the value of A3 right here, and we have the value of A2 here. Okay, so first I'll write A3. I'll say 10,000 into 1 plus 8 by 100 square minus A2. A2 is 10,000 into 1 plus 8 by 100. Now let's simplify this. Here you will see 10,000 1 plus 8 by 100 and 10,000 1 plus 8 by 100 is a common factor. So I'll take that outside the bracket and I'll write 10,000 1 plus 8 by 100 into 1 plus 8 by 100 minus 1. Okay, so now we can simplify within the parenthesis, and here you will see we have minus 1. So minus 1 and plus 1 will cancel out. So the final result will be 10,000 1 plus 8 by 100 into 8 by 100. Okay, so although we can simplify this further, we will not do it. We will keep the answer to this level only. Okay, now let us calculate the common difference for A2 minus A1 and see if we get the same result. Now what is A2? A2 is 10,000 into 1 plus 8 by 100 and minus A1. A1 is 10,000. Again, applying the rule of common factors. So here you'll see 10,000 and 10,000 is common. So I'll take that outside the bracket. We get 10,000 into 1 plus 8 by 100 minus 1. So here plus 1 and minus 1 cancel out each other. The resulting value is 10,000 into 8 by 100. So this is the difference that we found for A2 minus A1. So here we can clearly see that the difference we found by A3 minus A2, which is this, and the difference we calculated by A2 minus A1, which is this, are not equal. Right? So with this, we can say that the list of numbers that is presented in this situation is not an arithmetic progression. Thanks for watching this video. Remember to like, subscribe, and click on the bell button to get notified of new videos.